Good morning. Today we'll see the mineral admixtures. Myself, Dr. J. Sagaya Ruban, Department of Civil Engineering, Rohini College of Engineering and Technology. So, mineral admixtures normally we have four types used in concrete. One is fly ash, silica fume, GGPS, that is ground granulated blast furnace slag, and metakaolin. So what is fly ash? It is a fine powder that is a byproduct of burning pulverized coal in an electric generation power plant. It is a pozzolanic material. It's a substance containing aluminous and siliceous material that forms cement into the presence of water. When it is mixed with the lime and water, it forms a compound similar to the Portland cement. It is a prime material in blended cement, mosaic tiles, and the hollow blocks, among all other building material. When used in a concrete mix, it improves the strength and the segregation of the concrete and make it easier to form. In India, produce 75 million tons of fly ash every year, the disposal of which has become a very serious environmental problem. So the effective usage of fly ash into the concrete, it is an attracting serious consideration of concrete technologists and government. This table shows that the chemical composition of a fly ash. Some of the properties of fly ash. The fly ash sample is sieved 45 micron and the percentage retained on 45 micron is actually calculated. Also measured in a Leach-Adler method and blind specific apparatus. Specific gravity of fly ash ranges from lower value of 1.90 for a subbituminous ash for high of 2.96 for an iron-rich bituminous. Size and shape, particle size ranges from 10 to 100 micron. The shape of the fly is usually spherical glassy shape. The color is dependent upon the chemical and mineral constituents. Lime content in the fly ash gives the light color, where the brownish color is imparted by the presence of iron content. Dark gray to black color is typically attracted to an elevated and there are two classification, class F fly ash and class C fly ash. The classification based on chemical composition of fly ash, that is some of the silica, alumina, iron oxide percentage in a fine aggregate. Minimum of 70 percentage for a class F and minimum of 50 percentage for class. Why we are using this fly ash? It is a pozzolanic material. It can actually replace the part of Portland cement, result in more durable concrete, high ultimate strength, improve workability, improve cost economy of concrete, reduction is in heat of hydration, decrease density of concrete, more environmental friendly concrete. So we are used the fly ash as the alternate material for. So what are the effect of fly ash in the fresh concrete? The workability, setting time, bleeding and segregation, heat of hydration, density. These are some of the fresh concrete properties. Some of the application, it can be used as a prime material in many cement-based product. It can be used in a Portland cement concrete pavement or a PCC pavement. Fly ash provide economic benefit in construction project. It is used as an embankment and minefill, and it has increasingly gained acceptance by the Federal Highway Administration. The amount of fine agreed in concrete mix must be reduced to accommodate the additional volume of the. Some of the benefits of fly ash: cost effective, environmentally friendly, and reduces CO2 emissions. It reduces less water and have a great workability. High strength gain depending on its usage. It can be used as an admixture. It is a non-string material. Produce dense concrete with a smooth surface and sharp detail. reduce crack problem, permeability and bleeding, reduce heat of hydration, allow for a lower cement content for a similar slump when compared to no fly ash mixes. Some disadvantages. It having a slower strength gain, seasonal limitation, increased need for air entine admixtures, increase of salt scaling produced by higher proportion of fly ash. Next mineral admixtures is the silica fume. It is a pozzolanic material having a high pozzolanic activity. It is a byproduct from the electric arc furnace used in the manufacture of arc burners, silicon metal and silicon alloy. It has a high silica content of more than 80%. It is an excellent for use Portland cement. The composition, depending upon the product being made by the furnace, composition is also influenced by the furnace design. It most made of silica having percentage more than 80%. The other chemical composition include Fe2O3, Al2O3, CaNa2O, A2O is a small percentage. Unlike other by product like fly ash, silica fume from a single source has a little or no variation in chemical composition from one day to the physical characteristic. It should be in premium white and standard gray color. The specific gravity of silica fume concrete is 2.2. It specific surface area is 20,000 square meter per kg. Particle size is less than 1 micron with an average diameter of 0.1 micron. The shape of the particle is spherical. It should be in amorphous property in a fresh concrete, workable. It will be bleeding and segregation point of view, setting time, plastic shrinkage. It will affect the drying shrinkage, creep, workability. It reduces workability. Water demand increases in proportion of silica fume is added. Water demand is 1% for every 1% of replacement of cement. Lower slump and more cohesive mix. Bleeding and segregation. It reduces the silica fume particle find their way between two cement grains. Segregation is reduced as the concrete mix is more cohesive due to increasing in number of solid to solid contact point. From the discussion, we clear that silica fume reduces bleeding and segregation property of the setting time. Time result have shown that the initial setting time and final setting time is not greatly influenced. The increase may be 30 minutes or so. Last thing, fresh concrete is subject to a surface cracking is known as plastic shrinkage. Since the silica concrete show no bleeding, fresh concrete is subjected to the plastic shrinkage. Precaution should be taken as per normal. For a properties in a hardened concrete, drying shrinkage tested by the different researchers show that the long time shrinkage of concrete is not affected significantly by the addition of silica fume to the concrete. Creep of concrete containing silica fume will be lower than the corresponding Portland cement. Strength point of view, concrete containing silica fume shows outstanding performance in development of strength. Strength of 62 MBA to 80 MBA can be easily achieved. Silica fume forms the backbone of the high performance concrete due to the early high strength property. Some of the advantages of silica fume concrete, it has the high early compressive strength, high tensile flexural strength and modulus elasticity, very low permeability to chloride and water interaction, high bond strength, high electrical resistivity and low permeability. So this is about mineral admixtures. In this module, we see about the fly ash as well as the silica fume. Thank you for watching. Thank you.